Let's discuss rule of inference for quantified statement. I already discussed rule of inference for propositional logic involving and, or, implication. Here I will discuss rule of inference including universal quantifier and existential quantifier. So first rule of inference is universal instantiation. If for all x px is true, then p of c is true. If for all something true, that means for particular constant also it is true. Next is universal generalization. P of c for an arbitrary c. If p of c is true for any arbitrary constant, then for all it's also true. Next is existential instantiation. There exists x p of x means p of c for some element c. If for some x it is true, then c is some element, then for that p of c is true. Next is existential generalization. P of c for some element c, if it is true, then there exists x p of x if c belongs to x. These are the four rule of inference for universal and existential quantifier. Universal instantiation, universal generalization, existential instantiation, existential generalization. We'll apply this in example. Let's say example 9. So that the premises, everyone in this discrete mathematics class has taken a course in computer science and Marla is a student in this class, implies the conclusion Marla has taken the course in computer science. First, we need to take some propositional variable. Let d of x is in this discrete mathematics class and c of x is x has taken a course in computer science. And this statement, everyone in this discrete mathematics class has taken course in computer science, that we can write as for all x, that is for everyone who have taken discrete mathematics also taken computer science. So d of x implies c of x and Marla is a student in this class. So d of Marla is also true and we need to find conclusion as c of Marla. Means Marla has taken a course in computer science. We need to do one by one step. First given is for all x, d of x implies c of x. It's the premises. We can use the universal instantiation. By that it will be d of Marla implies c of Marla. Marla is some student and Marla including everyone. Marla is in this class, discrete mathematics class. So d of Marla implies c of Marla. It's by universal instantiation from 1. Another premises is given, that is d of Marla. So d of Marla is also true. Now d of Marla implies c of Marla is true and d of Marla is true. So what we can apply? We can apply the modus ponens. Like p implies q is true, p is true, then q cannot be false. So q should be true. That is by modus ponens. So here d of Marla implies c of Marla and d of Marla is true. Means c of Marla is also true. So modus ponens from 2 and 3. This is our 2, this is our 3. So by modus ponens from 2 and 3, we conclude that c of Marla. Means Marla has taken the course in computer science. So the student in discrete mathematics class has taken also course in computer science. And Marla is one of student. So she is also taken course in computer science. Let's say another example, example 10. So that the premises, a student in this class has not read the book and everyone in this class passed the first exam, implies the conclusion someone who passed the first exam has not read the book. So first we need to take some propositional variable for every small statement. Like c of x is in this class, b of x is x has read the book and p of x is x passed the first exam. Now first statement, a student in this class has not read the book. So from the class there is a student who have not read the book. So there exists x, there exists a student x, c of x. So that student is from this class and he have not read the book. So negation of B of X. There exists X, C of X and negation of B of X. The student is in this class and not read the book. Next statement, everyone in this class passed the first exam. So everyone, that's why it will be for all X, Cx implies P of X. So everyone from this class passed the exam. C of X is X belongs to this class and P of X means X passed the exam. And what is the conclusion? Someone who passed the first exam has not read the book. So from that all student, there is a student who have not read the book and passed the exam. So there exists X, P of X and negation of B of X. So he passed the exam but he not read the book. Let's solve this. So first premises given is there exists X, C of X and negation of B of X. We can use existential instantiation. So C of A and negation of B of A. Let A is a student. We know in case of AND it will be true if both are true. So here C of A is also true and negation of B of A is also true. So C of A is true and B of A is false. That's why negation of B of A is true. By simplification from 2, C of A is true. A is a student who is in this class. Next premises is for all X, C of X implies P of X. We can use universal instantiation. So C of A implies P of A. We use the universal instantiation. And here C of A is true. C of A is true means P of A is true by modus ponens from 3 and 5. If P implies Q is true, P is true, then Q is also true by modus ponens. So here C of A implies P of A is true. C of A is true means P of A is true. A is a student who is in this class and A also passed. We can also conclude that negation of B of A is true from 2 by simplification. In the same way, we conclude C of A is true. So here we found P of A is true, negation of B of A is true. So we can do AND like P of A and negation of B of A is true. We did conjunction from step 6 and 7. P of A is true means A is a student who passed and A has not read the book. Next, we can do universal generalization from 8. So there exists X, P of X and negation of B of X. So X is a student who passed the exam but not read the book. So I conclude that there is a student who passed the exam but not read the book. But practical, this is not possible. You have to read the book for passing the exam. In today's lecture, I discussed rule of inference for universal and existential quantifier. I also discussed two examples, example 9 and example 10, where we used rule of inference for quantifier and rule of inference for propositional logic. We used modus ponens and we used existential instantiation, universal instantiation, existential generalization, conjunction, simplification. So we used rule of inference from both. I already discussed two examples where we combine rule of inference of propositions and quantifier. Next I will discuss just formal way how we can combine. If this lecture is helpful for you, please like, share and subscribe. Thank you.